My name is Jacob Walker, and this is my new YouTube channel, Adequate Engineering. I intend this to be a channel where I design and create some fun projects as an excuse to learn new skills. A few years ago, I had a problem where I wanted to propose to my girlfriend, but all of the ring boxes offered in the store were just a very boring cube and they weren't very personal. I got a little carried away and ended up manufacturing this large wooden box. It's a puzzle book. Spent hundreds of hours on this, and I think it's a pretty cool project, so let's talk about it. When designing this project, I spent a lot of hours in this sketchbook drafting up various ideas for mechanisms that I could fit in a thin wooden box, and even how to design and manufacture that thin wooden box. My goal was to make a book with several pages that told the story of our relationship up to the moment where we got engaged, with a final page of the book presenting the ring so I could propose. I wanted to add all kinds of mechanisms and movements, but I wasn't sure exactly what that was going to look like, and a lot of this design didn't even get conceptualized until I'd finalized other aspects of the book and began manufacturing. This entire book is made from laser-cut 1/8" plywood and 3D printed components. On the outside, you're looking at a single piece of plywood cut with a living hinge so that it curves around the main hinge on the inside, but can be opened flat. Opening up, you see the first page and the hinge mechanism. This fully wooden hinge allows all the pages to rotate around a single axis, such that they lay flat to the left when opened. Each page has 4 connectors, as you see here. They're secured with a wooden clip hidden on the inside of the page. I struggled to fit all these components onto the wooden dowel since the hole size didn't fit the dowel size. I had to sand the rod down and then coat it in a thin layer of wax to avoid breaking too many parts. In retrospect, I should have corrected this in the laser cut design by increasing the size of the dowel rod, but this whole thing is basically a first draft. In the end, I didn't have any time to remake components, so I had to use what I had. The first page of this book shows our first date. This date started at the climbing wall on campus and then moved on to dinner and hanging out with some friends later on in the evening. It has a fairly simple mechanism with sliders allowing you to move climbers up and down the climbing wall on the page. When you move the right slider all the way to the top, a small key pops out that unlocks the second page. I'm not going to go through all the text on the left of each page, but I will take a second to show you the page lock mechanism. It doesn't work at all. The piece you see here was intended to lock each page closed, but I couldn't test it until I put it in the completed page, and I couldn't complete the page without gluing it shut. So the failed part is stuck in here with no way to fix it without remaking the entire page. The idea was to hook onto the next page with this rotating hook and then force the rotation to unlock the page by pressing the key into a slot at the top of the page. All of the pages contain the same hooked lock mechanism but different shaped keys. I don't even have all the original keys at this point since they all failed and I just didn't include them in the book when I presented it. But moving on from this broken lock, let's look at the next page. So page 2 was intended to be a slideshow of photos highlighting the best moments of our relationship. I tried many different ideas to accomplish this slideshow of pictures, but the page thickness severely limited my options. I ended up using a 3D printed rack and pinion system with this triangular cross-section billboard-like design that flipped between photos so I could fit 3 times the photos in the space at the expense of having to cut lines across each of these photos. You force the rotation by moving the rack gear up using the same key that was supposed to unlock the second page. Once you've rotated through all 3 sets of photos, this rack gear moves out of the way and releases a hidden drawer with the second key inside. There's no key here because again, the locks didn't work. But the hidden drawer was a fun concept that was unlocked by completing the puzzle on the page. This next page changed up the timeline just a bit. I'd originally planned to tell a story from our first date to the day that we got engaged, but page 3 actually ended up looking into the future and showing the life that we would have together once we were married. Like page 1, the mechanics here are quite simple. Primarily, you can unfold a 3D house and set it up with a tree and playset that are found hidden in this drawer at the bottom of the page. There's also an airplane that can move along the map here to represent traveling the world together. This flat pack house was fun to design, but I made the mistake of using duct tape for the hinges, and I would not recommend this. I should have tried to use fabric and glue or something like that instead. I can't reliably demonstrate this folding house anymore because the tape keeps falling off and I have no good way to replace it now that the page is assembled. This third page also has a locking mechanism that doesn't reliably work, so we can go ahead straight past that and move on to the fourth and final page and see where the ring is actually presented. This fourth and final page got much more time and detail than the rest of the book. It's also the first page that I designed, and it took me so long to design that I considered just throwing a cover on it and making this the entire project. Here we see a circle and a lever surrounded by laser engraved roses. When you turn this lever, a mechanical iris slowly opens and the ring is lifted up from beneath and rotated into position. This took forever to design, and it took a lot of space. It's the entire reason this book is so massive and why all the pages are as thick as they are. Let me show you how it works in the CAD model. Here we see the full page, isolated from the rest of the book. When I hide this front panel, you can see what's going on the inside. This lever is fixed to a stack of 2 gears. The top gear, shown in green, drives a large gray gear. The gray gear holds 8 long slots that direct the pedals to move and open the iris. The peg on the top of each of these pedals is restricted to a slotted path on the cover sheet that's hidden in this view. While the iris is opening, the medium-sized yellow gear is driving the lift and turn mechanism, as I named it. If I hide some of these other components, you can see how this works. The wooden platform rotates about a fixed peg. Its rotation is driven by the slots in the blue gear, and this ramped component, shown in red, is fixed in place and forces the wooden platform to rise up as it rotates. Most of this mechanism is 3D printed, with the exception of the pedals and the platform, since these are more visible components. I did my best to restrict 3D printed components to hidden components in the final product. So how exactly did I make this thing? Once I was confident I was going to be proposing, I spent some time sketching up ideas based on a project I'd seen on YouTube several years ago. I've linked that below. It quickly formed into the shape you see here. I ended up modeling everything in Fusion 360 as a parametric CAD model soon after. This means every feature, the page thicknesses, the height, the width, everything was defined by a variable that could be changed at any time, and the entire model would recalculate to reflect that new variable. I 3D printed all my prototypes for the mechanical structures within this book, but I didn't have the resources at the time to do any of the laser cutting prototyping. Once I had the complete CAD model, I was able to source a laser cutter at a local makerspace where I could cut all my components. I bought a bunch of 1/8" plywood stock material from a local lumber yard, and then I cut it down into 2x2 and 1x2 squares and rectangles that I could use for all my laser cutting work. In my Fusion 360 model, I made a copy of the entire book. I then took all the copied components that were laser cut, laid them flat onto the same plane, and arranged them into a 2x2 and 1x2 squares to match what I had in my real life stock. Once I had everything laid out in CAD, I could easily project all those flat components down onto a single plane and export a DXF file to a vector-based program. I used Inkscape. It's a free program. It's very capable. It's just a bit difficult to use. And in Inkscape, I added all the texts and the random vector art that you see. Then I took it all over to the makerspace, did a few tests to get my kerf settings correct. That's the thickness of the laser. Then I was able to offset all my lines and spend the next few evenings cutting out all the components. Once I had everything cut out, I had to line everything up, clamp it together, put some super glue in the creases, and give it about 10 minutes to dry before I'd clamp in the next few components and repeat. This is a bit more difficult than it should have been. The laser I was using at the makerspace had a warped bed, so some of my cuts were not straight like they should have been. So everything didn't fit together like it should have. But with the help of some sandpaper and my Dremel tool, I got everything fit together and working fine. Like a true engineer, I finished this project at 2 a.m. the night before I proposed. While the assembly might have been a bit rushed, it was all worth it, and in the end, I got this cool book, and I got to marry my best friend. Thanks for watching. I have a bunch more videos planned in the future. Hopefully I'll be able to get those put together here in not too long. Please like and subscribe, and share this with your friends if you find this interesting or you know anyone who's planning to propose anytime soon. Thanks.